at the 6th Annual Worcester Public Schools Science and Engineering Fair. Tonight we have over 140 projects from students in grades 5 through 12. 32 of our 33 elementary schools have sent projects to the fair. We have middle and high school projects as well. We have judges from the community, industry, colleges, many judges looking at these fabulous projects tonight.
Tonight is very crowded. There are so many projects, experimental and engineering, and we're showing the kids what it is to do science, really what it means to investigate something and follow it through. We have many more projects than in the past. We have almost every single school in Worcester represented here. Great parent support, great teacher support. 130, 140 kids, it's just a great experience.
Make an observation, ask a question, form a hypothesis and make a prediction, do a test or experimentation, analyze data and draw a conclusion. Scientific methods, scientific methods, scientific methods, scientific methods, scientific methods, scientific methods, scientific
Welcome to the awards ceremony for the Worcester Public Schools Science and Engineering Fair. These are the awards for students in middle and high school. Before we start, I would like to give a big round of applause to some people that made this event possible. And first, it's to the generosity of the Ecotarium facility and the Ecotarium staff opening up their doors to us tonight to have this science fair. So big round of applause to the Ecotarium. We also need to acknowledge, I think the reason we're here is for the kids. All of the students here that created science fair projects and worked on science fair, scientific process, and the engineering design process. Huge round of applause for my future scientists and engineers. And so students, hopefully we are able to someday acknowledge a great teacher that helped you, parent, guardian, friend, some mentor that helped you create your science fair project. I'd like to also thank all of our volunteers who came from local colleges, industry, and even some high school students came to judge tonight. And also all of our science fair volunteers. Many of your teachers were working here tonight to make sure that this event was a very big success for all of you. So a big round of applause for all of those people. So students, when we get to the award phase and I call out your name, I'm going to ask students when they come up to receive an award to stand here to my left in this space and smile for that camera because you're going to be on channel 11. All right? Okay, so we're going to start with the high school. And in the high school, I'm going to start with Judges Award of Merit and work my way up to the first place. So for high school, I have a Judges Award of Merit for 2 projects. I am looking for project number 101, Tania and Ama from the New Citizen Center.
Our experiment today is, do plants grown well in coffee or soapy water grow comparably to plants grown with water? According to our hypothesis, plants grown with coffee will grow comparably to plants grown with water, but plants grown with soapy water will not.
These are the materials that we use. The procedure are 9 similarly paired plants, categorized by group of 3. The 3 categories are water, coffee, and soapy water pollutants. Plants were grown for approximately 1 week with each of pollutants.
Plant growth with different pollutants. As you can see from the graph, coffee and water grew comparably at a height of 4 inches, whilst the soapy water grew at less of 3 inches. That means the soapy water is now growing. As you can see from the first day, The plants were looking healthy, and you can tell by looking at the flowers. The final day, water and coffee were still looking healthy, but soapy water was not surviving. Plant grew as expected with water and the flowers survived. Plant grew well with coffee and the flowers survived. Plant did not grow well with soapy water and the flowers did not survive. The purpose of this research is to benefit people who live in drought areas of the world. Like me, I used to be in Ghana, and it is not easy to find clean water for your plants. So we talked to our teachers and we decided to make this project. And in future or next time, we would like to investigate plant growth with different flavored coffees. Thank you.
And also, a Judge's Award of Merit to project number 102 from the Worcester Technical High School, Braden and Joshua.
Our project is on electrolytes, where we compare the amount of electrolytes in orange juice to the electrolytes in sports drinks. We saw that the makers of these sports drinks were claiming that they were better than regular water and orange juice. However, we tested that we believe that orange juice was better and it had more electrolytes than these sports drinks. So to do that, we tested with a multimeter to test the conductance of these sports drinks and the orange juice. A multimeter is a thing that'll find the electrical charge in it. And in the end, we found that pure orange juice has a higher amount of conductance than all the rest of the sports drinks. And the conductance is relative to the amount of electrolytes. People who play sports care about wanting to rejuvenate their body with replenishing their body with these electrolytes that'll keep them more prepared and ready to continue playing. By drinking orange juice, they'll get more electrolytes than these Gatorade and Powerade makers say they will.
And these are award winners. Photo op. All right, thank you. All right, you can introduce. Our fourth place winner in the high school category comes from North High School, and his name is Kofi Nemo. Come on up, Kofi.
My inspiration for this project all came because I play football, and I always, it's always an athlete's problem that they don't know what sports drinks to drink to help them have the most energy to perform better on the field. So I decided to make this project the MVP of ATP. I looked online to see the main ingredient of all sports drinks. They also talked about how cover everything up with marketing, when in fact all sports drinks are just mainly made out of sugar. That's where you get your energy from, sugar. So I want to find how much ATP is being produced in each of these drinks. So we wanted to use cellular respiration. Now, cellular respiration it has 4 stages. One of these stages being glycolysis. Now, in glycolysis, that's the breakdown of glucose into 2 pyruvate molecules, and it gets activated when when the cell puts in 2 ATP molecules. So just like how you deposit money into a bank, the cell deposits 2 ATP molecules into glycolysis. But in return, the cell produces 4 ATP molecules. So this is a really good bargain for the cell. And along with producing all those ATP molecules, it also produces NADH molecules. Then we move on to the next stage of cellular respiration, which is conversion. We are measuring oxygen. So oxygen is very present in our project. So this process moved into aerobic respiration, which is determined by the presence of oxygen. So we move on to the next cycle, which is the Krebs cycle. In the Krebs cycle, it basically takes the two pyruvate molecules and turns them into allyl coenzyme A. And what this does is it goes into the cycle, and then the cycle goes around twice because since there's two pyruvate molecules, and the total amount of ATP being produced from that is 34. And altogether, the cell is able to produce 38 molecules of ATP from just 1 gram of sugar. So now that I knew all of that, I wanted to know how can I put it into my experiment to see what drink actually has the highest production of CO2. Now, the output of CO2 that indirectly measures the production of ATP molecules. So we started off by doing our control, and we wanted to pick a sugar to put in our control. What we basically just did was we put together 8 grams of sugar with 150 millimeters of the sports drinks and yeast. So we added yeast into it so it could break down the sugars in the drinks. And this is our results that we got for each sports drink. So it turned out that these sports drinks were the ones that have the highest production of CO2. And my hypothesis before all of this was that NOS Energy will have the greatest output of CO2 because of the large amount of sugar it has in it per servings. So this is just the tip of the iceberg, you know. In my school, since everybody always asks me what drink is gonna benefit them on the field, now I know the answer, you know, and I'm gonna be able to tell them, and hopefully next year with this knowledge, we're gonna be able to improve on the football field.
Congratulations, Kofi. Congratulations. And thank you to Kofi. Yes. Our third place winner comes from Worcester Technical High School, project number 103, Grace and Victoria. And congratulations for you and your partner, yes? Yeah. Okay, thank you. All right. Thank you. Our second place winner comes from Worcester Technical High School, project number 104, and that is Yohara and Michaela.
My project is about sun protecting factor. I started with the idea that when people are exposed to the sun more than 10 minutes, depending on how high the temperature is, they get sunburned. So people buy some sun protector. When people buy sun protector, there is different type of SPF. SPF, it stands for sun protective factor. When people see 100, SPF 100, they think it's supposed to block the sun 100%. But when they wear it, they still get sunburned during a certain amount of time. There's different type of SPF, SPF 15, SPF 50, and then SPF 100. But I came up with the hypothesis that SPF 100 does not block the sun 100%, and actually might have the same UAV and UVB efficiency as SPF 50. I tested this theory out by using sun paper that's very sensitive to the light when you expose it to the light. I had a control that will block the sun 100%. The control was made out of construction paper to block the sun 100%. And I used plastic strips, and I put the different SPF on the paper. And I averaged them out. I averaged it out from 0 to 5. Compared to the control. As you can see, my average over here, my control is always 5. The SPF 50 was a 1.3, SPF 50 Kids was a 1.6, and SPF 100 was a 2. SPF 100 Sport was a 1.8. And as you can see over here, SPF 100 has the better average protection factor. But once you look over here, the SPF 100 costs $10.39, and the SPF 50 costs $7.97. But when you look at the protection factor, there's no really big difference. So I came up with the conclusion that it doesn't really matter what the SPF number is. It just matters how much you put it on during a certain amount of hours or a certain amount of time when you're exposed to the sun.
And our first place winner in the high school division comes to us from Doherty Memorial High School, project number 106, Tariana. And congratulations. Thank you. First place winner. All right, big round of applause for those high school students. Nice job. We'll now go to the 8th grade projects from the middle schools. We have a third place winner in the 8th grade. It is, the project is from University Park, project number 130, Allie and Dan. Congratulations. In second place, we are looking for project number 117 from Claremont Academy, Melanie. Congratulations.
My experiment is on icicles. My hypothesis is if icicles are the same diameter but different lengths, which one is capable of lasting longer? I did 2 experiments with this project, and 2 of these equal 1 project. So this one is 11 inches tall, and this one is 8 inches tall, and they're both 1.5 inches wide. This second experiment, this one is 10 inches tall, and this one is 5 inches tall. So we're gonna see which one is capable of lasting longer, the big one or the small one. Some facts that I've researched about is icicles usually form on the south side of buildings. Icicles only form when the sun is shining. Icicles only form when temperatures below freezing. When icicles quickly fall off buildings, the temperature is above 32 degrees. Falling icicles kill 1,000 people a year. And if it's really cold and you look at the front of your car, some of the icicles will be there. Some observations that I recorded during this experiment was I noticed that the icicle has a lot of bumps, and as it gets smaller, it loses its bumps. And as the icicle is melting, there's starting to form water beneath it. The icicle is starting to get thinner and thinner, and the icicle went down a few inches. As a result, for this experiment, the second icicle, which was 8 inches tall and 1.5 inches wide, was the one that lasted longer. The 11-inch tall one, it all melted, which I showed in a picture here. So it became this and turned into that. And the second experiment was that the third icicle one, which was this one that I showed here in these 2 pictures, the one that was 5 inches tall lasted longer. In conclusion, I was right about my experiment because the one that was the smallest icicle was the one that lasted longer. Next time, what I would do is test this outside because I put this on a windowsill, so I would see maybe if it would get different effects. And I would also take the icicles and put them like on a tray. Like instead of putting them up here, put them like down here, see if you get different results. And I would also, for these two facts, the one that says icicles usually form on the south side of buildings and icicles only form if the sun is shining, I would research why that is. And here's my model right here. So this is the snow right here. It's supposed to represent a roof. So this is the snow, and as the snow is melting, it creates the icicles.
And in the 8th grade division, our first place winner comes to us from Burncoat Middle School, project number 124, Aisling.
I did an experiment-based project this year called The End of Anonymous. My question was, is a software analysis program or a human better at telling who wrote something? The way we can tell who wrote something is by, however subconsciously, analyzing the writing style of the author. The writing style would sound like someone's handwriting, but actually the writing style is the words they use, the length of those words, the length of their sentences, the letters they start their words with, and that's kind of a little bit different for every person. They've also developed software to do the same thing for writing, and it takes a lot less time than reading it all out by yourself. The way I tested my question was to collect 2 essays each from 3 of my classmates, and then I put together packets of 2 essays that were written by the same person and 1 by another person. The essays were given to 5 adult judges, my teachers, other adults that I knew, and they were supposed to identify the outlier of the 3. I gave the same test to the computer, and the computer actually did better than the humans. It had an accuracy of 3 out of 5, sorry, and humans had an accuracy of 2 out of 5. The closeness in this was enough to make me doubt whether I could conclude either way. So I decided that the best way to figure out the real answer, whether humans were better at telling the difference or software was better, would be to do a larger scale project. I got my idea from a magazine I read. J.K. Rowling wrote a book under a pseudonym, and there was a rumor that she had written it, but there was no proof either way. So they analyzed this story she had written under a pseudonym and one of the Harry Potter books and some other books by other authors, and the results came back that she had written the book, and they were able to make her confess that she actually had written it. I liked that. On the website for this software, it said that the software was developed for people who work in old bookstores and they're trying to figure out if something is actually Shakespeare. There aren't a ton of benefits for regular people, but I thought it was a cool idea, and I wanted to test out using it and see how it worked.
And congratulations to the 8th grade winners. I'm thinking also at the end, we'll have plenty of opportunity for the extra photos. Feel free to come up and do those photos if you'd like. Okay, and moving on to our 7th grade projects, we're going to start with our Judges Award of Merit, which is project number 133 from Forest Grove Middle School. Congratulations to Sydney. Congratulations, Sydney. Nice job. In 7th grade, we are looking for a 4th place winner from Forest Grove Middle School, project number 112, Merida. Our third place winner is coming to us also from Forest Grove, and we are looking for project number 129 from Forest Grove, Ellie and Catherine. Congratulations. Thank you. Our second place winner is from Forest Grove, and we are looking for project number 110, Samantha. Congratulations, Samantha. And our first place winner in the 7th grade division comes to us from Forest Grove Middle School. I'm looking for project number 108, Nicola and Cecile. Thank you. And first place, congratulations. You know what, wave here. The projects were excellent. I looked at comments from the judges. All of these winning projects, the judges liked that the students knew what they were doing. They understood the science, the engineering. They could apply it to other situations. They spoke very well to the judges, very professional. The projects were outstanding. What I'd like to do now is invite all of the project winners up here for a group photo. And this is a great opportunity for parents and families to take that group photo. So all of the winners, please come up with your trophies, and I'm going to have you stand up here on the stage.
You form a hypothesis to explain what you observe. Then you make a prediction about how it's gonna go to a test with a control and a variable.
All right, so while the students are getting their group winner photo, if everyone thinks about these students, someday one of them could be our Nobel Prize winner. Someday one of them could design some new bioengineering piece of technology that will save someone's life or take us to the next level in our understanding of technology and engineering. This is the future of our science and engineering world, and I congratulate all of these students.
Things that you found. Then you ask a simple question, something that you wanna
is probably my favourite day all year long here at the Ecotarium. And I'll tell you why. How many of you guys who are here doing the science fair like to ask the question why? But why? Why? Tell me why. That was me as a kid. I always wanted to know why. And I grew up to be a science museum director. So I'm so impressed. I got to walk around and see some of the projects earlier today. And it was great to see budding chemists and physicists and biologists. And I was just blown away by the level of talent that's here in this room. We love partnering with Worcester Public Schools. It's great being here. We're glad you're here.
Thank you.
And good luck, everyone. Thank you.
So again, I want to just thank a whole bunch of people for making this such a huge success. First and foremost would be the Ecotarium. This is our 6th annual Science Engineering Fair. They've all been held at the Ecotarium. They get bigger and bigger every year, as you can see. But we're still so happy to be here where you can do science and go to the planetarium and check out the exhibits while you're waiting for your students to be judged. So this is all really great reasons to be here. Ecotarium gives their staff time to us. They do all kinds of setting up and breaking down, and so it works out really, really well. I also want to thank Worcester Public Schools. A lot of teachers were here tonight, school principals. We had some of the quadrant managers and some of the other people from 20 Irving Street. And again, I want to thank them for their support for such a great night. Teachers have really prepared students beautifully. The projects were outstanding. And every year, I know I say this every year, but every year they get better and better. I learned a lot of stuff from a lot of kids tonight. I saw robots that drew pictures, and I saw infinity mirrors, and I saw all kinds of things that were really, really cool. And I think that's what's so exciting. One of the things that makes me really happy is to see so many students excited about science. And as Mr. Cox was saying, this could be a career. This could absolutely turn into something that you do for the rest of your life if you really like science. So stay with it. So everyone had a good time? Good. Fifth graders, I hope to see you back here next year. Sixth graders, you'll be bumped up to upstairs next year, so you won't be down here with me. Also for the sixth graders, there's the regional science fair that a lot of kids are going to be going to at WPI, and that's in May, so that's another exciting event. As always, when we do the science fair, there are just so many great projects that it's hard for the judges to decide. And this year was harder than ever. And so because of that, we're going to be giving more than one prize for a couple of the places. I'm going to start out by giving out the awards to the 5th grade students, and then we'll give out the awards to the 6th grade students. So let me get my handy dandy clipboard. So, like I said, there are so many awards that are great that we can't sometimes decide. There are other awards where the judges say, you know, I really love this project and I want to give it a special award. And so we have an award that I'm going to give out first. It's called the Judges Award of Merit. Now I'm going to do my best to say people's names, but I usually do a terrible job. So try to, I'll read your project number also, so if you don't recognize your name, maybe you'll recognize the number. So my first Judges Award of Merit is going to Aiden Smith from West Tatnett. Over here. here. Congratulations. Our second award is going to Scott Gilbraith. Project 44. And that's from Turncoat Correct.
So you noticed that the larger gauge was better?
Yeah, it's more energy to travel.
That's very cool. So what was the best fact you found through research, or the best skill you think you gained from?
I really do like this painting thing.
Yeah, I like how you looked at the Princeton research, and it's really cool.
And electric eels actually is an interesting one too. In a study, they powered a Christmas tree with an electric eel.
Yeah.
The only problem with it is that electric eels don't constantly generate electricity. So it would be hard for something to power something continuously with them.
That's still awesome.
Yeah.
Very impressed, very impressed. Fantastic project.
Thank you.
So thank you, Scott.
You're welcome.
Keep it up.
All right, thank you.
And our last award for the Judges Award of Merit for 5th grade goes to Isaiah Oliver from Goddard School.
My hypothesis is from sodas. I think the diet will go the highest.
And why is that?
Because after I did my experiment, right here I wrote some ingredients down, and then once I looked at the back, I saw potassium benzoate and aspartame, and together they work as a force that were really strong together. So the Diet Coke went the highest because it forced it all the way up because the two ingredients work together as a team.
Yeah, that's okay. I mean, usually an hypothesis is something you do before, but sometimes it's hard to know what's going to happen, and then you do an experiment and you look to see what happened afterwards. Okay. And so.
For our 4th place winner, Isabella De Silva from Roosevelt.
Weights inside, different tracks and different shapes inside. And then my materials are shown. So I have to the size. Then my iPod stopwatch app, measuring tape, ruler, scale, and then phones to set up my
And as I said, so close, so I have another 4th place. This is for Tamer Mansour and Andy Oxford. And that's from Chandler Magnet.
Hi. The name of our project is Circuits. Sometimes it wasn't really brighter that much. It's basically just circuits now, with a Play-Doh together, and if you add them together, they would make squishy circuits. And you could make them light up and make sound. Like here. So they're pretty cool. They're basically circuits, but we kind of took an advantage more to it, and we added Play-Doh together instead of just a circuit. So yeah.
Okay, thanks, guys. Our 3rd place, we have Bernard Santos from City View School.
Yes, of course it does. Because it needs to withstand the factors of wind and things like that. And it also needs to be light enough for it to fly. Love it. Love it. That's why I love it. Because it shows the progression. It shows the Definitely.
And also Lois Duvall from Thorndike.
I did this because
because my Kindle got wet and I wanted to see I got curious and I wanted to see which desiccant makes my phone work again. Oatmeal works the best.
For second place, this could be one of the tough ones. Luigi Stulage, project number 66 from Columbus Park.
NASA's budget was going down, and fuel prices were going up for NASA. I wanted to use something that's around us and is free to use for rockets, and that was air, so I thought to use air compression. And if NASA actually made rockets like this, they'd use giant tanks filled with air, and the fins of the rocket would turn so the rocket would turn. And that was basically why I really thought, since NASA's space exploration has been going up with Project Orion and all that, and all the other new rockets they've been making, just like the idea of going to Mars. Its air is so strong when it's compressed, I thought, why not use it in a simple way? So, because taxpayers have been paying so much and they want to stop NASA, but this way it's free, so all they have to do is build the rockets.
Nice job. Also, second place is Catherine Bresnahan.
Hi, I'm Catherine Bresnahan. I'm from West Technic School, and I'm in 5th grade. And this project here, I did on does the size of a marble affected speed down an inclined plane, and I titled it Race for Peace.
Our first place winner for 5th grade is Isabella Archibald, project number 84.
My hypothesis was correct. Sweet was most effective by sense of smell. I figured that out by looking at my data sheet after I conducted the experiment, and I tallied the results, and this is just how many people got it right. So 6 people got sweet right with the nose plugged, and 9 people got sweet right with the nose unplugged. For sour, 7 people got sour right with their nose plugged, and 8 people got it right with their nose unplugged. For bitter, 4 people got it right with their nose plugged, and 5 people got it right with their nose unplugged. For salty, the same 8 people got salty right with their nose plugged and unplugged. And to figure out which was most affected, I figured out the difference between the greatest amount and the least amount, and the greatest difference was the sweet flavor. Well, I had a cold, and while we were having dinner, we were discussing what to do on my science project. And everybody was saying how good the food was and how great it was. I didn't really smell anything, and then the next day I couldn't taste anything really, and then the next day I could taste it more. So I wanted to figure out why sometimes some meals and for some flavors I could taste it more than other flavors and meals.
And also, Olgeta Danga and Emma from Tatnik Magnet project number 92. And it seems like it's succeeding. Ramon and Brent. Congratulations. You know what? So let's give a big hand to the 5th graders. Our 6th grade students. Same deal. So we've got lots of winners for 6th grade as well. First, our Judges Award of Merit. Jessica Soto from Cityview.
I was trying with a marshmallow, but I don't want to hit anybody.
Angle.
The angle was 130 degrees.
How far did it go?
11 feet and 7 inches.
Jessica's ambling down, also from Cityview. Ibrahim, number 42.
In a hurricane, the pressure below the house never changes. It's always the same, and then on top of the house, it changes. So you try to equalize the pressure below the house and on top of the house, and that would be the best. That would be the best roof against a hurricane. My hypothesis was roof number 2 would be because it is the steeper, it is the smallest roof. So I thought it was eventually more equal, but as I got along, it changes.
Okay, so you have your house 1, house 2, house 3. Awesome. And so how did you go through your experiment?
1.2 or something like that, and then we would record it. We would do the same thing on roof 1, 2, and 3, 1, 2.
Cool. Okay, and then so these are your.
Nice job. And Judges Award of Merit, Lily Inquist from Sullivan.
I took a marble and dropped it in a graduated cylinder. And I filled the graduated cylinder up with 8 different fluids, one at a time. And I recorded the time it took 7 times, and I found the average. So they're the average times, and those are the 7 trials for each of the fluids. And here are 8 scatter plots showing the times for each fluid in each trial. And that's a graph showing the average times. And my hypothesis was to predict the order of the fluid's viscosities from least viscous to most viscous, and my order was wrong. The actual order was water, corn oil, tomato juice, syrup, gravy, hand sanitizer, liquid soap, shampoo. My order was water, tomato juice, shampoo, gravy, hand sanitizer, liquid soap, syrup, and corn oil.
She's accepting the award for Lily. For our 4th place winners, we have Joni Hoxa from Sullivan Middle School.
Set up the couch by placing the insulation inside. So once you do that, you need some hot water in the center cup. And I mentioned it under 50 degrees. Because there's a hot temperature, so you get this temperature a lot faster. And here's the
And Alan Ross and George Ross from Grafton Street School.
Did you have any problems with the sauce all along while it's the quickest?
Twins. We got twins that win the award. Nice. For 6th grade, 3rd place winners, Maxie, at Toby out of Sullivan Middle School, Project 132.
Took like games in water insulation.
Yeah. Well, I did read a little bit about housing insulation, but not much. Like the most common one that I read was like double walls. We have
Also for 3rd place, Elizabeth Galaviv from Midland, 93.
Turn on the light, and my question was, I was using a scientific method, which color Lego plate will transmit the least amount of infrared light? So when it transmits, that means it's going through. And infrared light is light that has a wavelength greater than that of red light. So what I want to see is which color Lego plate will let the least amount of infrared light pass through. So infrared light is part of a bigger picture called the electromagnetic spectrum. And that's visible light and all the other electromagnetic waves. So basically what I do is I attach a Lego plate, like the black one, and then I hold on to it, and I want to see at what point it's going to reach or make contact. It's not on. And at that point it makes contact. This shows me how much was transmitted or how much wasn't transmitted. And just like my hypothesis was that the black one would transmit the least amount of infrared light because I know that black objects absorb most light. So I was thinking it would be the same. So and my hypothesis was true. It did transmit the least amount of infrared light. The red one, as you can see, transmitted the most. This is because if this electronic level of electrons matches the number of photons, photons are particles of light. If they match, they will absorb light. If they don't match, they will transmit light. It's like a key in a door. And this was my experiment. And here are my results. My conclusions of future research. I would like to try using different colored Lego plates. Maybe a neon colored Lego plate. See if a neon red has a different result than a regular red. So that's what I would like to try, and this is my project, and I hope you like this.
Our 2nd place winners. Simon Eber is the 2nd place winner. Project number 98. First place, we have Teddy Tona, project number 26.
The most popular food is black whale sunflower seeds. Originally, I thought it was because the birds would like a high energy warm treat that would keep them warm, and my hypothesis was correct.
And Mahir Sawad from Lakeview, project 85. again, I want to say how excited I am that we had so many schools represented at the science fair. I don't know if I mentioned or not, there were 11 schools the first year we did it. So you can imagine how we've grown to this. I want to thank you for your participation. I want to thank you for your time this afternoon and your enthusiasm. It was a great event. We look forward to seeing you next year. Careful getting out of here. It's a lot of people in a small space. Thank you again.
Well done.